So we are approaching the end of chapter 2. And chapter 2 has been about moving energy and matter through an ecosystem. And that's really important as we've discussed. We talked in the last section about energy. Energy can't be cycled. We have to have a continuous input of energy. For most of the planet, that input comes from the sun. It's captured by producers, transferred to consumers, up through food chains, food webs. We can use pyramids to model what it looks like. But energy is lost as it's used, so we can't cycle it. It can't be continuously reused. What we found out on the last section is that matter can be cycled. Matter can be cycled. Matter is never lost. It's rearranged but not lost. So you should have read about, or you will read about, and you should know anyway, oxygen. We need oxygen we get it from photosynthesis. We use it in respiration. The amount of oxygen, so oxygen is made up of the atom O, and there is no nu on the planet. And there is no loss from the planet. So the amount of oxygen, the atom oxygen, the element oxygen, does not change from day to day, year to year, eon to eon. It may not all be in the form of O2. It could be in water. It could be in other compounds that contain oxygen. But the total amount of the element oxygen has not changed since this planet was formed. We can say the same thing about carbon. There's no new carbon on the planet, and we haven't lost any carbon from the planet. The carbon could be in different compounds. It can be in glucose, it can be in carbon dioxide, it can be in carbon monoxide, but the total amount of carbon hasn't changed. We can say the same thing about phosphorus and nitrogen. We can say it for any one of the 92 natural elements on the planet. The amount of those has not changed. It's been moved. They've been moved from compound to compound, and they can be recycled or cycled through an ecosystem. But we don't get new ones, and we don't lose any of them. Energy, you lose as you use it. Matter, you do not. You just rearrange it. So let's take a look at a couple of important ways we cycle matter. Whoops, I don't want to save that. Here we go. No, don't save. So, oxygen. Oxygen we get from photosynthesis. This should be second nature to you now. Water goes into the light reactions. It is converted to hydrogen ions and oxygen, and in respiration it goes back to water. Now that's within the photosynthesis respiration reactions within the atmosphere, within the planet. The water, it starts out as precipitation from the sky, falls to the earth, makes its way to a water source. The water source evaporates, or it makes its way to plants and transpires to give us atmospheric water, which again falls in its many forms to give us. And I'm sure you've all talked about H2O or the water cycle. The water cycle is important because water is important, but also because water is a source of oxygen. Water is used in the light reactions to produce oxygen. That oxygen is the oxygen in the atmosphere. So the atmosphere has about 20% O2, and that 20% O2 comes from photosynthetic plants and other photosynthetic producers. So water cycle, oxygen cycle, tightly joined together. The other important one I want to talk about is the carbon dioxide or the carbon cycle. Just want to go over it again quickly because I know you've done it in your reading, and the slideshow gives you pretty good images of it. But CO2 is important because of photosynthesis again. CO2 goes into photosynthesis, gives us glucose, and that glucose is used in respiration to give us CO2. So with photosynthesis over here, respiration over here. Very similar to the oxygen, except the CO2 was going in photosynthesis and coming out in respiration. So here we have CO2 converted to glucose. The glucose is burned back to CO2. And this would be what we would call the short-term cycle. And here we're really talking about the carbons. Remember, glucose is C6. So we're not cycling CO2, we're cycling carbon. So this is a short-term cycle. It happens all the time. And then for carbon, there's also a long-term cycle because this was happening millions of years ago. The carbon dioxide was being converted to glucose and other carbon-containing compounds in plants and animals, and those plants and animals were buried underground. Then they have since converted into our oil and natural gas reserves. And so when we burn oil or natural gas, we're releasing carbon dioxide and other carbon compounds that were stored years ago. So we're adding new carbon dioxide to the atmosphere. So in addition to the short-term cycle, we are adding new carbon dioxide by burning fossil fuels, which is one of the reasons the amount of carbon dioxide in the atmosphere is going up, and that contributes to what is often referred to as global warming, but I would prefer you think of it as climate change. In any event, that's due to the fact that we're introducing carbon dioxide from reserves that are buried deep underground that were put there millions of years ago. So we have a water cycle, oxygen cycle, carbon dioxide cycle. You also have the nitrogen cycle and the phosphorus cycle. They're all important ways that we can move matter around an ecosystem. So the big message for chapter 2 is that energy, you can't cycle it, you can't reuse it. You need to have a continuous source of it coming in, because each time you use energy, some of it is lost. But each time you use matter, none of it is lost. It's rearranged, but it's not lost. So we don't run out of matter. We can recycle matter. All right, I'm going to put the last 5 assignments for chapter 2 up today for you, and tomorrow we'll do a overview of the important points of this chapter, and by the end of the week we'll have a formative up there that will cover all of chapter 2. Again, thanks for your effort. We are approaching the end of the year. I think my calculations tell me that after this week we have 3 full weeks, except that would also include Memorial Day. But in any event, I appreciate everyone who is checking out these videos and working on biology. I know these are tough times. Keep up the good work.